Hey guys, today we are talking about sigma notation and infinite geometric series. So this is the last little bit that we have to talk about with sequences and series. Our essential question for today is, who is this guy and why are they in my life? So what that guy is, that funky looking E, is actually the Greek letter sigma. Okay, we use sigma when we want to make sums. So we call this summation notation. And so when we see that there's that root word of sum inside of summation, we know that that's going to tell us we want to add it all up. That's what it means to find a sum, right? So how are we supposed to use this? Well, we have a couple of different parts to our summation notation. You're going to see a statement that's going to look like this whole thing right here. Anytime you see that, you know you're going to be adding up a bunch of numbers. So which numbers am I going to be adding up? Well, the first one I start with is this here down at the bottom, n equals 1. That means I'm going to start with this term. So since n equals 1, I'm going to start with the first term. So how am I supposed to find that first term? Well, we use this guy right here. This is our explicit rule. Now, we worked the last couple of days on finding that explicit rule, but this is how we find each term. Okay, so let's go ahead and do that. We'll find when n equals 1, that's over here, all we have to do is plug in 1 in for n. So here we take 2 times 1 plus 6. Well, that's really easy. 2 times 1 is 2, and then we add 6 to that, that's 8. Then we'll go ahead and do the next one, n equals 2. 2 times 2 plus 6. 2 times 2 is 4, plus 6, that's going to give us 10. And we would think, all right, well, how far am I supposed to go? And you may have seen with this box, you figure out how far we're supposed to go. That's what this number on top of the sigma is supposed to tell us. This tells us we want to add up to this term. So in this case, we have n equals 1 down at the bottom of the sigma, and then we have up to 5. That means we're adding the first through the fifth term. So let's go ahead and find all the remaining ones. When we plug in 3, 2 times 3 plus 6, 2 times 3 is 6, and 6 plus 6 is 12. You may already start to see the pattern. How are each of these increasing? Well, each time they are increasing by 2. So that means n equals 4, we're going to have 14, and n equals 5, we're going to have 16. Right? So that's easy enough, and all we have to do now is just go ahead and say that this whole thing is going to equal the sum of all of these numbers that we found. So we have 8 plus 10 plus 12 plus 14 plus 16. Okay? All you need to do real quick here is just punch this into your calculator. So go ahead and do that. So I've got my calculator page up and running, and all I do here, 8 plus 10 plus 12 plus 14 plus 16. Hit my enter button. Everything adds up to 61. Oh, but I see that here I made a little bit of a mistake. There's 11 instead of 10. That's easy enough to fix, right? No big deal. I know that that's actually going to be 60. So that means the sum of all of these first 5 terms is going to add up to 60. So this whole gross thing right here, it's just me finding out that I'm adding up to 60. And that's it. Okay? So let's go ahead and take a look at a couple more examples and see if we can't evaluate them. Next one, we have sigma of 3n squared. Okay? So let's go ahead and think about where are we going to start? We're going to start with the fourth term. And we're going to add up to the seventh term. Okay, so let's go ahead and find when n equals 4 off to the side here. It means I'm plugging 4 in for n. So we have 3 times 4 squared. Make sure you're doing your order of operations here. So we do exponents first. 4 squared is 16, and then 3 times 16, I know that is 48. Okay, when n is 5. So I'm finding my fifth term. 3 times 5 squared. 5 squared is 25. 3 times 25 is 75. I go ahead and find when n equals 6. And this is where you might want to start using your calculator, but I know 6 squared is 36, and 3 times 36 is going to give me 108. And then the last one that we need to find, because we only need to add up to the 7th term, so here we plug in 7. We have 3 times 7 squared is 49, and 3 times 49, I use my calculator real quick, and I find that that's 147. So this sum is all going to add up these four numbers that I found: 48 plus 75 plus 108 plus 47. And when I punch all that into my calculator, go ahead and do that along with me. Let's try real hard not to make any errors this time. 48 plus 75 plus 108 plus, nope, and there I see that I made an error. 108 plus 147. Again, I made another error, backspace, and hit enter, and we get the sum of 378. So this whole sum here is 378, and it's not too bad, right? It's the same thing that we've been doing, finding specific terms, but now we're just going to add them all up. And all we have to do is just practice with figuring out what the summation notation means. Look at this one. That's the n that we're going to start plugging in. Plug in this one as my last n. Find the terms, add them all up. Not too hard. So what I want you guys to do now, go ahead and take a look at what we have below. What if we're doing something with very large sums? If we're adding a lot of numbers? At this point, we want to try and actually use our summation formulas that we've talked about in the last classes. Okay? So with this first one, we have our sum. Again, we can use sigma sometimes, or sometimes we use this S sub n. It's a sum of the n terms that we have. And we have to look at our first term and our last term, and then our number of terms. So those are the things that we need to know here. Okay, so with this one, what we want to remember is that this one was for arithmetic sequences only. And then here we also ended up having this particular one where S sub n was equal to a sub 1 times 1 minus r to the nth power divided by 1 minus r. So we need to know a sub 1, we need to know r, and we need to know n. So the difference here, we have an exponent. So anytime we have that exponent, we know that that's going to mean we have multiplication going on. Also, you can remember that that term r was for geometric series or geometric sequences. So that means we're going to be looking at geometric series only. So if we happen to see where we have a rule that is going to be geometric, it has an exponent, we're going to use this bottom one. But if we see that our rule doesn't have an exponent, then we know it's going to be arithmetic, and we're going to follow this summation formula. So go ahead and watch the next video, and we'll take a look at a couple more examples of using these formulas.